Okay, hi guys. I owe you the echo. Okay, so just want to go through with you today what's echo about lah. Okay, so echo number one is the reflection of sound from surface back toward the listener. Okay, so in the first scenario, I'm going to give you a first example whereby there is no echo. Okay, the sound will travel from this guy down here who is bang. He create a bang sound lah. Okay, the sound will travel this way, like this, to the listener here. This is the listener. Okay, imagine the distance down here is 3,300 meter. So the time taken for the sound to travel, right, will be 3,300 meter divided by the speed of sound in air, which is about 330 meter per second. It will give you 10 seconds. So this is your final answer, 10 seconds. Okay, a classic example of this is like, for example, you are talking to your friends, or like, for example, the teacher is at the front of class talking to you. The time taken, there's a slight delay when the person creates a voice, create a sound, and it travels to that person. So like, for example, another one is like when Mr. Azwan is on the PA system. The PA system will have it will take some time for the PA system to transmit the sound to your ears. The second one is like when there's one echo only. So just want to go through with you how the example will be. Is like there's a person down here that will create a sound. There is a wall down here. Okay, how the sound will travel is from the bang sound, it will go to the wall, you'll get reflected back to the person that is listening. So this guy, he bang, he create a bang sound, and he also listen. So examples of these are like, for example, echolocations of bats and dolphins, or the sonar using submarine. Okay, so you just need to know that the sound travels from the bang to the wall and then reflect back to the user. So the total distance that the sound travel, this 3,300, is for this sound traveling this way. This 3,300 is for this sound traveling back this way. Okay, so the total distance is just 6,600 meter. So time taken, as usual again, is time taken equal to distance over speed, which gives you 20 seconds. Okay, the next example that I'm going to give you is one whereby there are two echoes, whereby there's a person down here that he bang. Then there'll be two walls, one wall here, one wall here. Okay, the distance between this cliff and this man down here is 330 meter. The distance between this cliff and the man is 660 meter. Okay, so because this 330 meter is a shorter distance, the sound will travel here and here first. Okay, so the time taken for the first echo, which is this one, is this one and this one is equal to 330 times 2. Okay, so therefore the time taken for the first echo is equal to this distance divided by the speed of sound in air, which gives me 2 seconds. Okay, the next thing whereby there's a second echo, because this 660 meter is a longer distance, the second sound will go like this, like that, which gives me 660 times 2. Okay, so then after that you calculate your time, which is 660 times 2 divided by 330 gives me 4 seconds. So therefore the first echo will take 2 seconds, the second echo will take 4 seconds. Okay, so this example is like, for example, you're in a valley, you hear two echoes, and the reason why is because there are two cliffs of different distance. Moving on. Okay, the next one is whereby there are two person with one echo. So there's a person down here that creates the sound. Okay, there's another person down here that receives the sound. Okay, this is actually a combination between example 1 and example 2. Okay, so the first sound is one whereby the bang down here, it travels to this listener. So the distance is 330 meter. 330 meter divided by 330 meter per second gives me 1 second. Okay, the second sound is one whereby it travels this distance. It travels this distance, which is 330 plus 330, this gives me 660. Then after that, there is a second sound whereby after that you get reflected, it goes back here this way. Okay, this is plus another 330. So total, this one down here is equal to 990 divided by 330, which gives me 3 seconds. Okay, this is just generally how reflection works. Okay, question can be a combination of example 1, 2, 3, and 4. There's a lot of examples. Okay, next up I want to talk about is the human audible range. Okay, human audible range is from 20 Hz to 20,000 Hz. Okay, 20 hertz is very low frequency, so those very low frequency voice, like for example Mr. Azwan's voice, he has quite a low frequency. But then if you have 20,000 hertz, right, it's something like Max when he was very young. He had very high pitch. Okay, so outside this range, right, we cannot hear anything. Moving on. So from 20 hertz to 20,000 hertz, this is your human audible range. Anything down here, I can't hear anything. Okay, anything that is less than 20 hertz this way is called infrasound. Okay, anything that is more than 20,000 hertz, it is called ultrasound. Okay, so here are some important pointers that I want to talk about. Okay, for speed of sound, right, the speed of sound does not change, right, if it is in the same medium. This is very important because when you use V equal F lambda, V will always be a constant. Okay, so in the event whereby your frequency increase, your wavelength have to decrease because using the formula V equal F lambda. And in the event whereby your lambda increase, your frequency have to decrease. Okay, and the last one is the frequency of sound will not change if the source frequency does not change. So like if I have a speaker in air versus a speaker in water and they are both playing the same note, the frequency will not change. Okay, so if there's a 10 hertz source using V equal F, there's a 10 hertz source using V equal F lambda, in air the speed of sound is 330 meter per second, the frequency is 10, I find that my wavelength is 33 meter. But in water, whereby the speed of sound is 1500, I divided it by the frequency, it gives me 150 meter. So therefore the wavelength of sound in water, if it is the same frequency, will be larger. And in solid, it will be about 400 to 500 meter. Okay, so that's just mainly what I wanted to cover for revision.